This is what this bulb right here measures the temperature. It has refrigerant in it and controls the pressure on the top side of the diaphragm right here. Okay, I'm going to pass that to you. That diaphragm pushes a rod that controls the position of the seat, the needle and seat inside of here. Don't know that I can get this apart, but we're going to try. There it is. There's the needle that controls, like I say, it controls the amount of refrigerant that goes through here. Now, notice the cage. That's what this part right here is called, with the spring and the adjustment and everything. You can adjust superheat on some you cannot. That would be done with a refrigerant wrench such as this. A little warning, small adjustments, never make large adjustments, small adjustments, and you better have some time. Every time you turn this thing about a quarter of a turn, you got to wait 10 to 15 minutes for it to stabilize. Time is money. So be prepared to be there for a little while. And you can see that this is the stem that does adjust the amount of spring pressure. Okay. Now, I'm not telling you not to adjust superheat, by no means. But don't go out on the system and start adjusting superheat just because you think it's wrong. Make sure that's the problem. Usually, they don't need adjusting. They may be when they first install, but unless somewhere along the line something has changed, it shouldn't need adjusting. A lot of TXVs are replaced for the wrong reason. If you have a compressor failure, then more than likely you're going to have carbon in the system, somewhere along the line, especially if it's a burnout. If the filter dryer does not catch it, this part right here will. See that fine mesh screen? Okay. That symptom is going to show up as an expansion valve that is not working properly, a stopped up expansion valve. Most people think that it's the valve itself. They forget to check the strainer that goes to it. Like I said, I've seen a lot of times when these things have been replaced, wasn't no problem at all except the stopped up screen. Okay? Okay. Now, expansion valves do have another characteristic that we need to cover, and that's internal and external equalization. Now, internal actually would have the suction pressure. This one's internal. The suction pressure finds its way to the bottom of the diaphragm internally. Notice there's no other port on here, just two ports. The high side coming in, the liquid coming in, this part going to the evaporator. External, you see this other line. Okay? Don't just cap this line off. I've seen folks do that, they wonder why it didn't work. This line is connected to the bottom of that diaphragm. In fact, that one going around is actually an externally equalized expansion valve. And if you'll notice on the side of the top that there's that port on the side actually has a channel that will route the suction pressure to the bottom of the diaphragm. That's the reason sometimes you'll see a small line coming off the suction line on the exit. What we're doing is we're measuring the pressure at the same point that we're taking the temperature to determine the true superheat. A coil such as this one. Now this one actually had a piston type metering device in it, but I'm going to treat it as if it were one with a diaphragm. Okay, if it had, or not a diaphragm, but one that actually had a TXV. If it had a distributor, that's what this is right here, going to the different circuits, then it could not measure the true suction pressure or the evaporator pressure because there is pressure drop across this distributor. Plus, this one is so long that there would be another problem of pressure differential between the inlet and the outlet of the evaporator. So we would never get a true superheat. We've got to be able to measure the pressure at the point that we're taking the temperature in order to get true superheat. And that's what that Instructor equalized TXV is about. By the way, that little device right there on this particular coil is what meters the refrigerant going in. This is considered as a fixed orifice. Okay? These are not. Okay? Anytime you have a fixed orifice, we go back to the charging procedures, that's when you're going to be looking at superheat to charge the system up correctly. TXVs, you can use pressure differentials or pressure, high and low pressures. Again, don't limit your thinking to think that cap tubes are restricted or what they call fixed orifice type systems. It's only going to be on small stuff. I have had a 225-ton chiller that had a disket in it. A disket is nothing in the world like a big washer with a predetermined hole in the middle of the washer, and that's what restricts the refrigerant between the high and the low side. Simple, no moving parts. And you know, 225 tons is not a small system. So if it falls into the category, if you will, sort of like a capillary tube system or a fixed orifice system, you can see how that you cannot say that cap tubes are only on small things or fixed orifices are only on small things. In the future, in fact today, we have got electronic expansion valves. They haven't fully hit the market like I think they should. One is because electronics has, well, the development of it was one thing, but now the price has got to come down. It's like any other electronics. The more that's going to be out there, the better the price is going to be. And you will see these electronic expansion valves, I feel for certain, in the future. Very much so in the future. And they are much more precise. They can control the superheat much better, much quicker, much easier to adjust. Instead of that 15 to 20 minutes per turn, we're talking about go ahead and dial it in and you're done. So the future is looking very, very good. Do y'all know how much superheat a coil could have, and when would it be the most efficient? Zero. If I had zero superheat on an evaporator outlet, that means that my entire evaporator is doing the job. The problem is with zero superheat, I don't ensure that I'm not going to be able to get liquid back to the compressor. Well, the electronics still can't do that, but we can get the superheat much lower, and I see the future having the efficiency to go up even better on the systems by being able to control that superheat through the metering device. Any questions about metering devices? Just keep in mind, all this complicated stuff we talked about, the bottom line, what is it? It's some sort of restrictor. How it works, so be it. It's good to know, but the bottom line is it's doing one thing, and that is separating the high side from the low side, metering the amount of refrigerant that the evaporator needs. Okay, thank y'all.